After T days, the amount of thorium-234 in a sample is A of T is equal to 35 times E raised to the negative 0.029 T micrograms. A. How much was there initially? B. How much is there after a week? C. When is there just 1 microgram left? D. What is the half-life of thorium-234? Well, to begin, let's explore this problem numerically, and then we'll verify our answers symbolically. On your calculator, go to y equals to enter the function. Enter 35 times E raised to the negative 0.029x. And then to explore the problem numerically, we'll create a table of values. So go to Table Set, which is second window. To answer the question, how much was there initially, we need to let time equal 0. So we'll put table start at 0. And then T represents the number of days. We want to determine how much there is after a week. That will be after 7 days. When is there just 1 microgram left? Well, we can scroll through the table to determine how many days that will be. So we'll just leave our table increment on 1. That way we'll start at day 0 and then increment 1 day at a time. Make sure that the independent and dependent variables are both on auto. Once your table is set up, go to Table, which is second graph. And we see right away that the initial amount is 35 micrograms. How much is there after a week? And we just scroll through the table until we get to 7. And we see that after 7 days or 1 week, there are 28.57 micrograms. When is there just 1 microgram left? Well, we just scroll through until Y1 becomes close to 1. We can see that Y1 changes from 1.0175, which is above 1, to 0.98842, which is below 1, between 122 and 123 days. So somewhere around 122 to 123 days, there will be just 1 microgram left. What is the half-life of thorium-234? Well, we've determined initially that there were 35 micrograms, so we need to determine how long will it take for there to be half of that. Well, half of 35 is 17.5. So let's scroll back up until we find 17.5 for Y1. 17.5 is bigger than 17.45, and it's less than 17.964. So that tells us that the half-life is somewhere between 23 and 24 days. Well, let's see if we can verify these answers symbolically. For part A, how much was there initially? Well, initially time is equal to 0, so we need to find A of 0. To find A of 0, we substitute 0 for T. We get 35 times E to the negative 0.029 times 0. Well, 0 times any number is 0, and a non-zero number raised to the 0 power is 1, and 1 times 35 is 35. So the initial amount is 35. So our answer to part A is 35 micrograms. For part B, we're asked how much is there after a week? Well, a week is 7 days, so we need to substitute 7 for T. In other words, evaluate A of 7. To evaluate a of 7, we'll use our calculator. The result is approximately 28.6. So our answer to part B is 28.6 micrograms. For part C, we're asked, when is there just 1 microgram left? In order to answer this question, we'll need to substitute 1 for A of t and then solve for t. Our first step will be to divide both sides by 35. The resulting equation is 1/35 is equal to e raised to the negative 0.029t power. To undo the exponentiation base e, we'll need to take the natural logarithm of both sides. The resultant equation is the natural logarithm of 1/35 is equal to negative 0.029t. Finally, to undo the multiplication by negative 0.029, we'll need to divide both sides by negative 0.029. So t is equal to the natural logarithm of 1/35 divided by negative 0.029. To evaluate this expression, use your calculator. The result is approximately 123 days. For part D, we're asked, what is the half-life of thorium-234? Well, we determined that initially there were 35 micrograms. So what we need to do is to determine the amount of time that it takes for the 35 micrograms to be cut in half to 17.5. So we'll substitute 17.5 for A of t and then solve for t. To solve this equation, we'll just mimic the steps that we used in part C. First of all, we'll divide both sides by 35. The resultant equation is 1/2 is equal to e raised to the negative 0.029t power. Next, we take the natural logarithm of both sides. The resulting equation is the natural logarithm of 1/2 is equal to negative 0.029t. For our last step, we divide both sides by negative 0.029. So the half-life is equal to the natural logarithm of 1/2 divided by negative 0.029. To evaluate this expression, we use our calculator. The half-life is approximately 23.9 days.